Congratulations, you have your new Pi, and hopefully you've had a chance to install Raspbian and get past your first boot and the initial setup. If not, head on over to www.barryhubbard.com for information on how to load an operating system onto your new Pi. So, on to today's project. Today you'll get to play with resistors, LEDs, wire, a breadboard, and of course your Pi. One of the really cool features about the Raspberry Pi is its GPIO pins. What is a GPIO pin? A GPIO stands for General Purpose Input and Output. What this means is that you can write a program on your Pi, and you can use that to either draw information in or send information and control things outside of your Pi. It's kind of a cool thing. In this project, we're going to use our Pi to control a single LED, or light emitting diode. Now, full instructions for how to do this are on the website, but here are a few things that you need to keep in mind. Electricity will always flow in a loop. It always starts at a positive voltage and goes to ground. For this project, the positive voltage will be supplied by a GPIO pins, and we will use one of the Pi's ground pins to ground our circuit. Keep in mind, GPIO pins are not designed to power external circuits like lights and motors. It's strong enough to run our LED, but if you want to use a motor or lights on it, you need some external circuitry or you'll run the risk of burning out the Pi. Now, LEDs are diodes, and diodes only allow electricity to flow in one direction, from positive to negative. So it's very important that you know which is the positive side of an LED and which is the negative side. The positive side of an LED is always going to be the long wire, called a lead. The shorter lead is the negative side. Also, LEDs allow electricity to flow, but they don't really provide much resistance. If electricity is allowed to flow around our circuit without resistance, it's going to flow as fast as it can, and this is called a short circuit, and results in a very high current. This is another thing that can break your Pi and your LED, so be careful. If we want to use an LED, we have to use it with a resistor. We need to make it so that all the electrons that flow through our LED also flow through that resistor. That's called connecting them in series. We are going to use a 1 kilo ohm resistor for our circuit. Not all resistors are the same. They each have 3 or 4 color bands on them, and each color represents a certain number, multiplier, or tolerance. And you can see on this chart exactly how all of that works. Now, be careful to use the right color combination and the combination that is shown in the instructions. If you use too high of a resistance, it's going to make it so that your LED either doesn't light or is so dim that you're not even going to see it. If you use too low of a resistance, it's going to allow too much electricity to flow. Your current's going to be too high, and you may wind up letting the magic smoke out of either the LED or your Pi. And a funny thing about that magic smoke, electronics don't work without magic smoke. And even worse, once that magic smoke gets out, you can't get it back in. So be careful. Well, that's about it. When you get all done, if you followed all the directions, you should have a little program to turn on your LED. And it should look something like this. I hope you have fun. Remember, for full details on this or any project, go to www.barryhubbard.com and click on the Raspberry Pi tab to see all sorts of information about your Pi and things that you can do with it.